Chapter 16, Part C. In this chapter, we are going to talk about the predictive models. The last part of the chapter 16, it talks about the predictive models. Let's see what are they. Predictive models provides a way to evaluate products or designs without directly involving the users. It's like you are predicting how your user will use a particular system or part of the system. Because here you are not involving the users directly, it is going to be less expensive than the other ways of testing where the users are involved. And some kind of other inspections are also expensive. Like, for example, in carrying out the heuristics, we need experts, right? And in A/B testing, we have to employ or use large number of audience. So arranging for all these things makes the testing expensive. However, in predictive model, we predict how the users will see the system and we don't involve the users, so that's why it becomes less expensive. Its usefulness is limited to the systems with predictable tasks. For example, you will check how the voicemail system is working, how the smartphone feature is working, and dedicated mobile devices are working based on the knowledge of expert error-free behavior. It's like you are like assuming it's like something you are trying to test for which you have a good knowledge about. So you can easily predict like what type of error user can make here, and then you rectify that error. For example, if you are trying to set up a new iPhone for your mother and you are an iPhone user from long time, so it is very easy for you to set up the iPhone for your mother, and then you will predefine some things like making the text font size bigger, okay, giving some audio kind of hints, and using like you feel like she is going to call you many times in a day, so you can have your contact in the wallpaper so that she can make a quick call. So as an expert user, you can think about an error-free behavior or error-free scenario for the user by predicting what she can do, what she needs more. Okay, so it's like this one. Okay. Another example is if you can imagine that you are a part of a team developing a voicemail system for smartphones. You want to ensure that the system is easy to use and efficient for users without needing to contact expensive user testing, which can be time consuming and costly. Here is you can here is how you can predict the models to evaluate the voicemail. For example, the first one, understanding the model and defining the evaluation criteria for it, building the predictive model and executing it and testing it, analyzing the results and adjustment and refining your voicemail according to your prediction. So this is how the predictive model works. The basic aim of a predictive model is not involving the user, then it makes it less expensive, and you use your expert error-free behavior and you predict your knowledge of how the user is going to behave with a particular for a particular feature of your app, and then you make it error-free. This is about the predictive model. Now let's move to the Fitts law. You would have seen a game of dart, target setting. For example, the more close you bring your target, the more accurate it is and the more visible it is. The Fitts law does the same thing. The Fitts law predicts that the time to point at an object using a device is a function of distance from the target and the object size. So it says that if the target is less, okay, the accuracy of reaching to that object is more. If the target is far, then reaching to that object or the target is difficult. The farther away and the smaller the object is, the longer the time to locate it and point. So it tells that all the important information should be kept near All the important information should be kept near, okay, so that it takes less time to locate that information and use it. It is particularly useful for determining where on a screen to position an object. Okay, for example, you see we have the shopping cart always on the right side upper corner. So that is the place for seeing the shopping cart. Similarly, the favorite icon is kept just near a product. For example, if I want to add a product into my favorite list, I can just click it there because it is very near to me. The fit law says that if an object is near to the access of the users uses it more frequently and more easily. And this is how we make that object more useful to serve the purpose. Fitts law is useful for evaluating systems for which the time to locate an object is very important. It's like, the first information, it says that the 5 seconds of viewing any digital product, the first 5 seconds of using the digital product is very important. In this 5 seconds, if the design, if the digital product can take our attention, grab our attention, then we want to use it. Otherwise, we feel that it is not, you know, easy to use, it is not interesting, and then we stop using that particular app. The last one says that fit law is useful for evaluating the systems for which the time to locate an object is important. For example, smartphones, handheld devices, and mobile devices. Okay, now let's see the summary. In this chapter, we have talked about inspections. Inspections are nothing but checking the functional prototype, checking that the system is working properly, understanding what are the problems that we identify during inspection, and trying to improve it. User testing and heuristics are very helpful in carrying out the inspections, which relieves or which uncovers many usability problems. Design lines can be used to make heuristics, or heuristics are, developed on design guidelines. WCAG provides guidance for evaluating the accessibility of websites. Walkthroughs are focused on evaluating smaller parts of prototype or product by giving a practical demo, a step-by-step practical demo. Analytics involves collecting the data about people's activity on the website and see which parts are used mostly. A/B testing is a form of large scale experiments which involves version A and version B of the same product with a minor change inside it. The feedback is gathered for both of the versions, and the more better feedback is evaluated on, one of them that is used. Fit laws can be used to predict expert error-free performance for clearly defined tasks with limited key presses. It's like, when I want to, it's a human behavior. When we open a website, we want to do the job with less number of clicks. If you are shopping from noon.com and amazon.com, if either one of them is taking longer number of clicks, you don't prefer to use that website over the use of other. So Fitt's law says that the limited key presses should be needed in order to perform any task. For example, to evaluate key press sequence for handheld devices and the position of objects on a small screen also plays an important role. That completes our chapter 16, parts A, part B, and part C, where we have talked about inspections, we have talked about analytics, and we have talked about models. Thank you for watching.